Hello, I'm Jose Garza.
And I'm Tim Chang.
We're both first year SDM students and we're Project Volta.
It's been a couple weeks since we last talked and a lot's happened, so we want to catch you guys up on it. When we first started on this project, we wanted to conduct image recognition on daily updated Earth imagery provided by the San Francisco startup Planet. And do this for the purpose of providing helpful information for NGOs and government investigators to better combat child slavery on Lake Volta in Ghana. We concluded that the resolution and image quality of Planet's images, those limitations of high temporal resolution and low spatial resolution images just would not lend well towards identifying changes in fish boat locations and fish farm structures. So we moved to a reduced scope of trying to do the same idea but with synthetic data. So introducing artificial artifacts onto images and demonstrating it as a proof of concept of the original scope.
However, we dug a little deeper into the technologies that we would have to apply in order to do image recognition. And we concluded that image recognition is very hard. Given our limited programming background and the limited time that we had to for accomplishing this project, we decided that we would have to rescope again. And this was tough, but we still wanted to do something to leverage technology to help the most oppressed and needy. And furthermore, we didn't want to let go of our original intent of doing something to address the problems at Lake Volta.
Alright, so we decided to develop an application that would enable anonymous reporting of nefarious activities on the lake. It would enable geotagged reports to be logged onto a database and then add each of these new coordinates onto a continuously updated GeoJSON file and display these reports onto a map shown as a heat map that would enable quick identification of potential hotspots of illegal activities for investigators to follow up on.
That's right. So now, let us walk you through the code we prepared.
Our project is structured in 4 files, 2 HTML files, a JavaScript file, and a GeoJSON file. The first HTML file is the user-facing file. Here we initially call the libraries that are relevant to our project, including jQuery, Firebase, JS, and the Mapbox API. Then we have the styling section, which is written in CSS for the page. And then finally next we have the section that is dedicated to the location and reporting capability. So here we have the function of retrieving the user's geolocation in lat long, and then the field in which the user can input report information of what they see.
The rest of the HTML file is dedicated to providing a map. And in this map, we basically look to add the user reports, the geotag user reports, and create a heat map. The heat map capability was provided by Mapbox. It's already part of their API. And basically you can see here that we call a GeoJSON file that contains the coordinates of our users' reports.
The second HTML file is the About page, in which we provide information about the project itself, a little bit of information about us as a team, and some information on how to use the product. And we were able to leverage some really neat CSS templates provided by W3 School. We were able to take those templates and tailor it to our needs, which worked out pretty well.
Next, we have our run.js JavaScript file, which houses most of the functions that were used in the HTML file. So we started off by declaring some relevant variables, and then we start declaring the functions. We start off with a function called geofindme that basically acquires the latitude and the longitude of the user's location. We continue with another function called startup that is loaded together with the body of the HTML and basically acquires the user location with geofindme and then retrieves a report ID from the current report ID from the database. we continue with a function called getReport, which basically retrieves the value of the text that was written down by the users on our HTML. We have the next function that is called writeUserReport that takes that text and pushes it into our database hosted at Firebase. And then we have a function used to retrieve information from the database.
And finally, we have the GeoJSON file, which is just a special format of JSON that comprises coordinate locations for points that we want to map on a map. In this case, we have populated this file with mock data points, in which we can use to test the heat map portion of our product. It's pulled up on the geojson.io website. This is a tool that allows us to map geographic points on the map and convert these points, their coordinates of these points, into a GeoJSON format which we'll use for our purposes.
These points in the GeoJSON format are used by one of our HTML files to display a heat map using Mapbox's API. Here you can see each of the coordinates mapped on this map of Lake Volta, in which each of the red markers would ideally correspond to a user report. These user reports are then clustered by proximity to give the appearance of the heat map. Up here you can see the form that is used by the users to input their text, the text of the report. And right now there's this message that says unable to acquire your location, but that is only because this computer that we're using to record a video is not equipped with a GPS. Then we also have this button right here that basically triggers one of the functions in our JavaScript file that retrieves the text and pushes it into our database that is hosted at Firebase. Here you can see that we have a counter for the reports that is functioning as our report ID, and then we have 3 test reports that include the coordinates of the user as well as the text of the report.
We also have an About page in which we introduce some more background information on the project itself. We also introduce ourselves as the team and also give some more information on how to generate a report using our user interface. All of this is, of course, run on the DigitalOcean virtual machine. We have installed an Apache server on this machine, and it seems to be working pretty well for us.
The only technology piece that our project is missing to work is basically to find a way to write down data from the database to the GeoJSON file so that user reports can be continually updated.
Yeah, that's the one piece that we weren't able to get right. We got really close, but ran out of time right at the end. And if we had a little more time, we'd probably address that. But also to make this product really useful, we'd probably try to find a way, make a way in which the data that's retrieved from this tool would be better utilized by NGOs and investigators, possibly by creating an API for this application.
Yeah, that's basically the final goal, providing these relevant parties with the information they need to address the problems at Lake Volta. So that's our project. Hope you liked it.
Thank you.
Thank you.